Okay, this is the second video for our Lab 8 concerning binary search trees, and what I'd like to walk through is the insert function so you can see some of the details of optional and how it works within this lab. So again, here's this optional class that comes as part of Java, and you can make an optional of anything. We're going to make optionals of tree nodes, and they can contain a null value or not. They have a couple methods called isPresent. Get is going to get that value back. There's an isEmpty method. There's a couple other things that we'll be able to use. So let's start coding here. Insert. I want to insert a new node containing the value, that's my parameter, but I want to preserve that binary search tree ordering. Okay, there's a lot of instructions here that will help you as you do this to remind you of how that algorithm works. But our first thing we need to do is say, wait, this t is going to be comparable, so I can do the compare to function on it. Int, what is my comparison? I am going to say value dot compare to value. Oh, but wait a second. Value is what I'm using up here, and value is the name of my parameter. I should be saying this dot value. Okay, so this dot value compare to value. Now that will figure out if the thing that is at this node is less than or equal to or greater than the number that's coming in. Now that's a little bit backwards from how we've been talking about it. So let's put the this dot value in there. So int, my comparison is, hey, is this new thing trying to be added smaller, equal to, or greater than the value stored at this node? Now if it's smaller, we want to go left. If it's greater, we want to go right. And if it's equal, we just want to ignore it. Okay, so now we can set up our if statement. So if comp is less than 0, that means that the value coming in is smaller than the value stored at this node. So what do I want to do? I want to go to the left. The left might exist, it might not. I have to do a check. I have to say, hey, if it's the case that left is empty, I found the place where I need to add it. So I found a node that exists that has no left, and I'm supposed to go left. Well, left equals value. I'm like, oh no, that doesn't work. Left equals tree node. No, I can't make a tree node because left is of type optional. So left equals optional dot of a new tree node based on value. Okay, that is a little strange, but this left is an optional wrapper around a tree node, and this is the way we're going to be making an optional. Okay, but if it's not empty, what do I have to do? I have to do recursion, and I would like to say left dot insert value. That would make sense if left was a tree node, but left is not a tree node. It's an optional, so I have to say left optional. Give me that tree node. And once I get the tree node out, that's when it's legal to call insert. And this is my recursion to get down. Okay. Here's the other side. If it compares greater than 0, then now I need to go the other way. If right dot is empty, then I need to make a new right equals a new optional of my tree node based on the value. Okay, otherwise, dot get the actual tree node, and then recursively call insert on that value. Okay, this is how we are going to write insert. Do our comparison, and then if the parameter is less than this dot value, do the left child stuff. If it's greater than, do the right child stuff. Now if the child that I'm looking at, left or right, is empty, replace it with a new optional thing. Otherwise, recursively call insert on the tree node part of that child. Hopefully this gets you started. You want to do something very similar to this when you get down to write contains. You're going to be doing a comparison, figuring out if it's equal to, less, or greater, doing other stuff. Your task is to return a Boolean. You want to know if this value is in the tree, whereas up here we had to create a new spot when it was not in the tree. Okay, so good luck with your coding. Let me know if you have questions. I will see you on Tuesday afternoon.